Chemical safety. Workers in laboratories are not only exposed to pathogenic microorganisms but also to chemical hazards. It is important that they have proper knowledge of the toxic effects of these chemicals. Several chemicals adversely affect the health of those who handle them or inhale their vapors. Some chemicals are known to be carcinogenic or teratogenic. Exposure to hazardous chemicals may occur by inhalation, contact, ingestion, through broken skin. We all use some chemicals in the laboratory, but do we know how to use them safely? Some don't that we do. Overflowing waste bins, scattered chemical bottles, loose wires, eating in labs, cluttered tables, etc. How do we get a chemical safety program started? 8 suggested steps are: have a written hazard communication program for employees. Properly label hazardous chemical containers. Have MSDS or SDS, Material Safety Data Sheets, on file for each hazardous chemical available. Practice safe storage of chemicals. Practice safe disposal of chemicals. Use mitigating strategies such as chemical fume hoods, formalin monitoring devices. Train employees about potential hazards. NCE or incident or accident reporting. Maintain records about the entire program. This is an important chapter in the Lab Safety Manual which has to be read and understood completely. Hazard communication. Right to know. The lab staff have the right to know what chemicals they are using and how to use them, what are the risks and hazards, and what precautions should be employed. All these are adequately indicated through several mechanisms like verbal, visual, pictograms. Most chemicals employ more than one of these mechanisms. Verbal. H and P phrases, hazard and precautions. R and S phrases, risk and safety phrases. MSDS or SDS, Material Safety Data Sheets. The visual hazard communications are of 3 kinds. Labels, pictograms, GHS EU Directive, NFPA, National Fire Protection Association, Diamond, HMIG, Hazardous Material Identification Guide, Color Bar. Hazardous chemicals are classified under GHS. 3 main aspects of hazard are identified: physical, health, and environmental. GHS hazard pictograms and the correlated exemplary hazard classes. Physical hazards: explosives, flammable liquids, oxidizing liquids, compressed gases, corrosive to metals. Health hazards: acute toxicity, skin corrosion, skin irritation, CMR or STOT aspiration hazard. Environmental hazards: hazardous to the aquatic environment. Note that CMR stands for carcinogenic, germ cell mutagenic, toxic to reproduction, and STOT stands for specific target organ toxicity. The NFPA Diamond, National Fire Protection Association. Another warning system is NFPA. There are 4 diamonds within the one large diamond. Red indicates fire hazard, blue indicating health hazard, white indicating a specific hazard, and yellow indicating reactivity. Let's take the example of the NFPA diamond for sodium hypochlorite. Sodium hypochlorite is a commonly used chemical in all labs. The NFPA says category 3 for health, 0 for fire and reactivity, and oxidizing under specific hazard. HMIG Color Bar or Hazardous Material Identification Guide. HMIG Color Bar is another system commonly used. It has blue for health, red for flammability, orange for physical hazard, that is reactivity, and white for personal protection. Fire and reactivity, both components of the physical hazards, are separate in this one. Example of a warning label on acetone showing both NFPA and HMIG and pictogram is seen here. Another example of a combined warning label on toluene. Fire is classified as a physical hazard as in the case of GHS. Target organ effects are also specified. PPEs are illustrated. The right side shows separate NFPA and HMIG. Gradation of the new GHS. The new GHS differs in its gradations from HMIG and NFPA. When HMIG and NFPA classifies green to red as 0 to 4, GHS classifies it in the other direction. Green to red is 5 to 1. Moving from hazard pictogram to safety pictogram. Safety or precautionary phrases, pictograms. Let us examine a few safety pictograms. You may see these cautions on different chemicals. You need to identify the use of these PPEs as indicated. H and P phrases, hazard and precautions. Now we can look at some H and P phrases which is part of GHS. Here the list of H hazard phrases H200 to H227 shows the code with its explanation. For example, H200 indicates unstable explosive. Similarly, there is a list of P phrases which are general and prevention precautionary statements. For example, P102 in general precautionary statements indicates keep out of reach of children, and P201 in prevention precautionary statements indicates obtain special instructions before use. R and S phrases, risk and safety phrases. This list shows the old system of R, risk, and S, safety phrases. Here is an example of a comprehensive label with GHS pictograms and warnings on top along with HNP as well as RNS phrases. MSDS or SDS, Material Safety Data Sheets. This is another strong communication system. It is more detailed and gives much more information. The following aspects are addressed through a MSDS. 1. Identification of the substance or mixture and of the company or undertaking. 2. Hazards identification. 3. Composition or information on the ingredients. 4. First aid measures. 5. Firefighting measures. 6. Accidental release measures. 7. Handling and storage. 8. Exposure controls or personal protection. 9. Physical and chemical properties. 10. Stability and reactivity. 11. Toxicological information. 12. Ecological information. 13. Disposal considerations. 14. Transport information. 15. Regulatory information. And 16. Other information. Here is an example of page 1 of MSDS of sodium hypochlorite solution giving all this detailed information. Most MSDS sheets of chemicals used in the laboratory can be obtained from the manufacturer either in a print form or downloaded. Ensure that the MSDS sheets are available at the point of use and are compiled in the documents of all chemicals and reagents used in the laboratory. They should be read and understood by the staff. Labeling in your lab. Most reagents come with adequate labels. If you are partitioning any chemicals or reagents, remember to label them thus. 1. The identity or contents of that container. 2. Appropriate hazard warnings including words, pictures, symbols or combinations that convey the health and or the physical hazards of the container's contents. The name and address of the chemical manufacturer and the emergency telephone number. Containers that are too small to be labeled should be kept in a large labeled container. Existing labels on containers carrying hazardous chemicals should not be removed or defaced. Date of preparation and or the date placed in service and where appropriate, the date of expiration wherever warranted. Unlabeled containers of chemicals should not be opened. Labels can be purchased or can be custom made by the laboratory. Safe storage of chemicals. Read the storage instructions on MSDS of all your chemicals. Minimize the quantities and container sizes kept in the lab. Only the required amounts of chemicals necessary for daily use should be stored in the laboratory. Bulk stock should be kept in specially designated rooms or buildings. Store chemicals away from sources of heat and direct sunlight. Do not store hazardous liquids on shelves above eye level. Place the solvents requiring refrigeration in special flammable storage refrigerators. Store flammable liquids in flammable storage cabinets. Never pour flammable liquids down the drain because they can cause an explosion. Storage instructions read: in a dry place, in a well ventilated place, in a closed container, locked up, in a corrosive resistant container, protected from sunlight, do not expose to temperatures exceeding, look at the labels, and away from other material. Safe disposal. Dispose of unwanted chemicals promptly. Follow local regulations. The 2016 BMW Management Rules. Black bags with cytotoxic logo. Disposal by incineration at 1200 degrees centigrade. Do not pour chemicals into the drain. Refer to manufacturer or supplier for recovery and recycling. Return to manufacturer for disposal. Formaldehyde. Formaldehyde 3.74% used for specimen preservation is the most common toxic chemical to which autopsy or histopathology workers are exposed. The chemical is volatile and toxic and causes irritation to the eyes, the mucous membranes, and the skin, and is associated with an increased risk for all cancers. Occupational Safety and Health Administration, that is OSHA, regulations specify an exposure limit of 0.75 parts per million as an 8-hour time-weighted average and 2 parts per million for short-term, that is 15-minute exposures. Limit exposure to formaldehyde in the following manner. At present, air quality monitoring systems are not available in India, so purchasing good formalin hoods must be considered. The use of formalin hoods reduces exposure to formalin fumes. Cover all specimen buckets where the organs may be deposited for fixation. Collect discarded formalin-soaked towels and other formalin-soaked waste in a bag at the grossing table. Periodically spray a formalin neutralizing agent available commercially in the waste as it is filled. Seal off the bag when it is filled. Formalin badges to indicate the exposure level may be available in the near future. Training. Have a calendared training program, especially in areas that use chemicals, and have evaluation of that training. Actions to be taken in the event of a significant chemical spill. Notify the appropriate safety officer. Evacuate non-essential personnel from the area. Attend to persons who may have been contaminated. If the spilled material is flammable, extinguish all open flames, turn off the gas in the room and adjacent areas, open windows, if possible, and switch off electrical equipment that may spark. Avoid breathing vapor from spilled material. Establish exhaust ventilation if it is safe to do so. Secure the necessary items to clean up the spill. Reporting. Start an non-conforming event, incident, accident reporting system. Encourage reporting. Do chemical safety audits and discuss with higher authorities. For more details on chemical safety, please refer to the module on facility management and safety.